you can solve any quadratic equation ever given to you, no matter what type of solutions you're going to run into. It can always be solved using the quadratic formula. But there are a couple things that have to be true. It has to be in standard form, which means highest degree to lowest degree, so ax squared plus bx plus c, and it has to be set equal to 0. It absolutely has to be set equal to 0. And then if it is, you can go ahead and solve it using the quadratic formula. We learned our little song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's what we learned yesterday. Now understand, I want you to all look up here, I want to make a point. If we had a quadratic like this, 2x squared minus 3x plus 9 is equal to 1. Is it equal to 0? So could we, even though there's an a, b, and c value, could we solve using the quadratic formula as is?
No.
No, we first make sure it's set equal to 0. So we subtract 1, right? We have an 8. And then we could do the quadratic formula. Do you understand the couple rules that I'm looking at? Sweet. Okay, and also, yesterday, like I said, 9 out of 10 students can't type it in, cannot get the quadratic formula correct. You guys did awesome yesterday, because you put parentheses exactly where I told you, you didn't get lazy, you typed it in how I said. Please don't start to, or you'll start getting them wrong, okay? So let's do problem 24. So we're going to extend our knowledge a little bit, let's do 24. So we have, just a second. We'll go through this problem. So first of all, it's in standard form, it's set equal to 0. So we can begin. My a value is positive 1, my b value is negative 8, my c value is positive 7. So then we do our quadratic formula. I'm going to write it down. And yes, I write it down every time because I just like to, so I make sure I don't make any errors anywhere. And it's all over 2a. Okay, so plugging things in. So it's x equals the opposite of b. Well, it was negative 8, so it's going to be positive 8, right? So 8 plus and minus the square root of b squared. We always use parentheses. So negative 8 squared minus 4 times a is 1, times c, which is 7. And then that's all over 2 times 1. So then from there, I caution you to be very careful. Only type this part into your calculator because we're not always going to have it come out perfectly. And then we have to break it down by hand otherwise. So don't type in the square root part. Just type in that part in your calculator and write it out again. X equals 8 plus and minus. We still have the square root, but you're going to calculate that piece. Yep, positive 36. And that's all over 2 times 1, which is 2. Now this is always where I go off to the side and say, what's the square root of 36? Positive 6. So we don't have the square root of 36, we have a 6. Now that we've simplified. So we have x is equal to 8 plus and minus 6 all over 2. And then we learned yesterday that, yeah, you can go ahead and split that up. So you can write it as x is equal to 8 plus 6 over 2. Now you can write it as x is equal to 8 minus 6 over 2. Now do not just type that into your calculator and hit enter. You'll get it wrong. You have to actually add at the top. So we get 14 over 2. And now you can type it in, which is, so we get x is equal to 7. There's one of our answers. And then 8 minus 6. So we have 2 over 2, which is, so x is equal to 1. There's our 2 solutions. So we actually could have solved this one by factoring. Way easier, right? Factoring is way easier than the quadratic formula in my book. But we still got the same answers. And today we're practicing the quadratic formula.
Isn't it negative 8 though? Because b is negative 8.
Was b negative 8?
Yeah. 6.
No, it was negative 8, and then you do the opposite of b, which is positive 8. The formula is x equals the opposite of b, okay. So it would have been positive 8. Okay, good questions. Okay, let's do one more where we're going to have an imaginary solution. Here we go.
What number was that?
Oh dear. 24 or something. Ask your neighbor that was paying attention. Okay, let's do 26. Yeah. So 26. This one is actually going to come out imaginary. So the quadratic formula is our favorite type of solving when it comes to imaginary solutions. Otherwise, we can't find them. So here we go. It's first of all, in standard form, it's set equal to 0. My A value is 2, B value is -5, my C value is 16. Now at this point, I'm going to just go through and plug in as I go. So I say to myself, x equals -b, so that means opposite of b, so wouldn't that be +5? Or is that going to bug anybody? Do I need to write out the quadratic formula? Are you sure? So x equals the opposite of b, which is +5. We have plus and minus the square root of b squared. So we're doing -5 squared minus 4 times a is 2, times c, which c is 16. And it's all over 2 times 2. And I had a secondary 3 kid come up to me today, and he was doing one of these, and he didn't come from my class originally, but he put only this piece over 4. Only this piece over 4. And we talked about that yesterday, right? It's like a huge no-no. It's all over 2 times 2. Okay, so simplifying. Underneath the square root, everybody should simplify this piece in your calculator. Type it in. You got negative what? Negative 103. Well, that's still under the square root. So we have the square root of negative 103, and that's all over 2 times 2 is 4. Right, everybody? So this is where you go off to the side, as always, and we say, what's the square root of negative 103? I'm going to remind you of something. Isn't this the same thing as negative 1 times 103? Isn't negative 103 the same thing as negative 1 times 103? Now, can anyone remember what the square root of negative 1 is equal to? I. So we have an I on the outside. And now we still have the square root of 103. Does it break down? Let's all try. Take your calculator. 103 divided by 2, divided by 3, 4, 5, 6, 7, 8, 9, 10. Can you find anything? No. So it's a prime number. So we couldn't pull out 103. So it's left under the house. So under the house is 103. Questions on how I simplified just that piece? So what if this would have been this instead? What if, well, let's say that 103 broke down into, this is a horrible example, but 2 times 2. Wouldn't we pull out 2 and an I?
Should be 2i.
Should be 2i, yeah.
Where did you get that 5?
That's our b value.
And so you put the b value left.
Well, it's x equals negative b, so that's what comes first. So, right? But does that make sense? X equals the opposite of b. B was -5, so that is what b is. Negative b is k. So really, guys, this piece became I square roots of 103. So I'm going to rewrite it. X is equal to 5 plus and minus I square roots of 103 over 4. Now, do all 3 things divide by something in common? No. So there's our answer. Today I'm going to allow you to keep your answers together, because I think after yesterday we understand that there's 2 answers there, right? We could split it up. Could you split it up? If you could, then we're good. I'll let you keep them together today. Are we all good?
Yes.
Okay, are you sure? Okay. So, sweet. All right, so do problem 24. Oh, one more thing. Sorry, I forgot this first hour too. Okay, so everybody think, this will really help you later on. So how many solutions did we get?
2.
Are they imaginary?
No.
No, so we got 2 real solutions. What if it was, so the only time we have imaginary solutions is if there's an I, right?
Yes.
So even if it's 2 plus the square root of 5, it's still a real solution, right? Okay, awesome. So one more. That's the second part of your answer. With number 26, we had how many solutions? Nope. If you say 1, I've got to make you split it up. How many do we have? 2. And what kind of solutions are they? Imaginary. So our second answer would be we got 2 imaginary solutions.
Do we have to write that too?
Yes, you do. So now, what if we had the square root of 0? Wouldn't that be, okay, so I'll go to here. So what if we had this, like, for example, 8 plus and minus the square root of 0 over 2? Isn't that 8 plus and minus 0 over 2?
Yeah.
Isn't 8 plus 0 and 8 minus 0 the same thing? So we would get 1 real solution. 0 is not imaginary, right? So we'd only have 1 real solution if that comes out to be 0. Does that make sense? Okay.
But when we still have 2?
You have 2, but it's only, remember how it's with a multiplicity of 2. So yeah, we have 2, it happens twice, but we only have 1 real solution.
So if it's 0, there's 1.
Right, 1 real solution. Okay, go. Do these problems. 24 through 29. Practice them. Be careful. Type it in just like I showed you. Don't get lazy.
Is there any more calculators?
So the discriminant is b squared minus 4 times a times c. The discriminant is just this part of the quadratic. Do you all understand that? From that piece of the quadratic formula, can't we automatically tell if we're going to have real number solutions or imaginary solutions? Yeah? Because if that's a negative under there, isn't that 2 imaginary solutions we're going to have? Yeah? Under the square root, the b squared minus 4ac. If it's not a negative, aren't we going to have 2 real solutions? Okay? And so what if it's 0? What if it's a 0 under there? Didn't we only get 1 real solution? Does that make sense, everybody? So from the discriminant, you can tell how many solutions and what type of solutions you're going to get. So that's what we're going to do next. So this is the rule. Now back in my day, when I was in high school, my teacher said, memorize this. Well, I had no idea where it came from. Couldn't remember it after the test. So, but if you understand where the discriminant's from, then you don't have to memorize anything. You just think about it. Okay, I'm looking at the discriminant. It's under the square root. So if it's negative, I'm going to have 2 imaginary solutions. Do you see how to think of it? If it's a positive number, we're going to have 2 real solutions. And if it's 0, we have 1 real. Yes?
Are you talking about the negative 4?
No, the discriminant, b squared minus 4 times a times c. So let's do an example.
But there's always going to be a negative in there.
No, when you calculate it, a lot of times it comes out to be not negative. Yes. Yes.
How do you tell by just looking at it?
We calculate the discriminant. And then we look at that number, and if it's positive, we have 2 real solutions. If it's negative, we'll have 2 imaginary solutions. So we have to calculate the discriminant part to know. Does that make sense, everybody? So, but if I said find the solutions, you'd have to go through the whole process. Do you understand what I'm asking here? Okay, how many solutions do you have and what kind? That's all I'm asking. So let's just use the discriminant. So on number 36, I'm asking you not to find the actual solutions. I'm asking you how many solutions are you going to get and what kind. So I say I'm just going to look at the discriminant, which is b squared minus 4 times a times c. So my a value is 1, my b value is 11, and my c value is negative 10. So I'm going to plug it into the discriminant here. So b squared would be 11 squared minus 4 times a, which is 1, times c, which is negative 10. Type that into your calculator. What did you get? Should have got 161. So now think about it. We didn't calculate the solutions. We're just looking at the discriminant. The discriminant is underneath the square root. So think about it. Are there going to be imaginary solutions?
Yeah.
Is there a negative under the square root?
Okay, no, I get it.
So they're not imaginary solutions, and there's going to be 2 real solutions, right? So from the discriminant, I know there are 2 real solutions. I don't know the solutions. I didn't ask you to find them on this problem. Do you understand what I'm saying? So if this was a negative 161, we'd change our answer to, well, it would have been a negative under the square root. It would have been an I, right? So it would be 2 imaginary solutions. Does everybody understand? If I calculated the discriminant and got 0, I know that it's 0 under the square root. So I know the square root is 0, 0. So we'd only have 1 real solution. Do you all understand what I'm doing? I'm not going to do any more examples then. So I want you to do problems 36 to 41. You really should be able to finish this worksheet by the end of the hour.